Will quantum entanglement change the world if this turns out to be a real thing? Bill Nye just dropped a shocking warning. A quantum computer has detected a signal that could be a parallel universe shifter. This surprising breakthrough suggests that our world might be overlapping with another hidden reality, with quantum computers unlocking new secrets all the time. Bill Nye urges everyone to watch closely, continue to explore, to continue to build particle accelerators. Could this discovery open the door to alternate dimensions and change our view of the cosmos forever? Stay tuned for more Out of This World revelations. Simultaneous molecule measurement in a groundbreaking experiment. Scientists recorded the same molecule behaving in two distant locations at nearly the same time, once in Silicon Valley and again in London. Researchers began by isolating a single molecule and setting up a series of quantum gate interactions on a state-of-the-art quantum computer in Silicon Valley. Instruments carefully manipulated the molecule's quantum state, while in London similar equipment recorded coinciding changes, almost as if nothing separated the two measurements. Laboratory teams meticulously checked each step, ensuring there was no hardware malfunction or environmental interference. Repeated tests confirmed these simultaneous fluctuations were real and followed a definite repeating pattern. This phenomenon left scientists both astounded and excited. Under ordinary conditions, one would expect the molecule's behavior to be confined to its local environment. Instead, the coordinated measurements across continents hint at a hidden connection between separate regions of our reality. The experiment opens the possibility that information could be shifting between dimensions, causing the same molecule to be measured in different locations as if guided by an unseen shifter. Researchers work to rule out conventional explanations by calibrating their instruments, isolating variables, and reproducing the experiments consistently. Their findings suggest that quantum particles may be influenced by forces beyond the classical boundaries of time and space. Such an observation forces us to reconsider our understanding of causality and connectivity in this new picture. Quantum systems could be sensitive to disturbances coming from alternate domains, implying that our seemingly isolated experiments might be in contact with other layers of existence. This idea transforms a routine measurement into a potential window into unexplored realms. The experiment is now prompting further study into the nature of quantum interactions, fueling debates about whether our universe is truly self-contained or part of a larger web with parallel counterparts. As investigations continue, scientists remain hopeful that these surprising observations will lead to even greater breakthroughs in understanding the hidden fabric of reality, revealing a parallel universe shifter. Recent advances in quantum computing have led to a discovery that many believe could be the first tangible sign of a parallel universe shifter. In a carefully controlled experiment, researchers observed a mysterious anomaly in the behavior of quantum states, one that cannot be easily explained by conventional physics. The anomaly manifested as a distinct pattern in the data, suggesting that information might be crossing between dimensions. The experiment began with a well-calibrated quantum processor that manipulated specific quantum states using a series of gate operations. As the team measured the particle state, they found that the readings showed subtle fluctuations far beyond what was expected from ordinary quantum noise. Rather than being random errors or experimental glitches, the fluctuations followed a clear and repeatable pattern. To many scientists' surprise, these signals hinted that the quantum system was being influenced by something external, possibly an interaction with an alternate layer of reality. This phenomenon is being investigated through the lens of the many worlds interpretation of quantum mechanics. According to this theory, every quantum event splits the universe into multiple parallel realities, each reflecting a different outcome. In the context of the experiment, the anomaly appears as though information from one of these alternate realities is bleeding into our own. In simple terms, the quantum processor may be acting as a bridge, picking up signals from a hidden realm beyond our conventional three-dimensional space to rule out common sources of error. The research team repeated the measurement process multiple times and at different locations. Each time the same consistent pattern emerged. The reproducibility of this effect has convinced many observers that this is not just an experimental quirk but a genuine phenomenon if indeed the anomaly proves to be a parallel universe shifter. It could mean that our universe is not isolated, rather it may constantly interact with other unseen dimensions. The implications of this discovery are profound. It challenges our basic understanding of time and space and opens up new questions about the structure of our reality. Scientists are now planning further experiments designed to explore the possibility of interdimensional communication and to better determine the origin of these patent fluctuations. Should future tests confirm these findings, the breakthrough may well mark the beginning of an entirely new era in quantum physics, one where the boundaries between parallel worlds are not absolute but instead dynamic and intertwined. Breaking the theoretical barrier. For decades, the existence of alternate realities remained a tantalizing idea, confined to theoretical physics and the realms of science fiction. Conventional wisdom held that our universe was self-contained, with the concept of multiple overlapping worlds existing only in abstract mathematical models. However, a recent quantum computing experiment appears to have shattered that barrier, offering what might be the first tangible evidence of interdimensional interactions in a rigorously controlled laboratory setup. Researchers were running standard quantum gate operations when the unexpected occurred. Instead of behaving as anticipated, specific quantum states began to fluctuate in a distinctly patterned way. These irregularities could not be easily dismissed as hardware glitches, random noise, or routine experimental errors. The precision of the data suggested that a subtle external influence was at work, one that might hint at interference from parallel realities. The significance of this breakthrough lies in its challenge to long-held theoretical limits. Quantum mechanics already introduced us to surprising phenomena like superposition, where particles can exist in multiple states at once, and tunneling, which allows particles to cross classically impenetrable barriers. Even the notion of entanglement, famously described by Einstein as spooky action at a distance. People, when your sophomoric view of the world, Isaac Newton was wrong. Isaac was pretty flipping right, defied common sense by linking particles across vast distances. Yet despite these remarkable behaviors, the idea that our universe could intermittently interact with an adjacent reality was once thought to be purely speculative. The new findings are now beginning to bridge that gap between theory and observation. Researchers speculate that what they observed might be a delicate interference pattern, evidence of information seeping in from a hidden dimension. If subsequent experiments confirm that these fluctuations are not mere artifacts of the quantum system, it would imply that our reality is more porous than we have imagined. A tiny window may have opened through which information from a parallel universe is influencing our own. Breaking this theoretical barrier is revolutionary. Not only does it challenge the very definition of solidity in our physical existence, but it also suggests that the many worlds interpretation, where every quantum event branches into multiple realities, might hold more than just mathematical interest. It encourages the scientific community to re-examine the nature of time, space, and the limits of what we can detect and control. As experiments continue and data accumulates, the possibility of directly mapping or even manipulating these parallel realms could transform our approach to physics and technology, forever altering our understanding of the cosmos. Quantum computing is the key to unlocking hidden dimensions. Recent advances in quantum computing are rapidly changing the way we view our universe, suggesting that our three-dimensional reality may be just one layer of a far more complex, multidimensional cosmos. Quantum computers use bits that exist in multiple states at once thanks to the property of superposition. This ability makes them not only powerful computational devices, but also uniquely suited to detect and analyze subtle phenomena that could hint at hidden dimensions in a typical experiment. Scientists program quantum gates to manipulate qubits in well-controlled settings. When these qubits interact, phenomena like quantum entanglement occur, where changes in one particle instantly affect another, regardless of distance. Researchers believe that entanglement, along with quantum tunneling, where particles pass through barriers in seemingly impossible ways, may be the key to noticing how different layers of reality interact. These same principles are what experts suspect might reveal the presence of hidden dimensions. The idea is that our universe might be interwoven with alternate realities, each acting like an overlapping layer of existence as quantum computers process a vast number of quantum interactions at speeds no traditional computer can match. They become exceptional tools for detecting minute fluctuations. Such disturbances, if measured accurately,